purpose of this tutorial is to show you a practical usage of Cramer Profiler for categorization purposes. We are going to find analogs of a target chemical and use them to predict its carcinogenicity. Let's get started. We start with a target chemical with identification number 1615801. Go to Input and add it using the CAS option. Once the chemical is on the data matrix, go to the Profiling section and apply the Cramer Profiler. The chemical is profiled as high class 3 due to the profiling path indicated here. This information can be used to search for analogs. For more details about the profiling results, please watch the corresponding video tutorial. With the current example, we are interested to find out analogs of our target chemical that have been tested for carcinogenicity. First, we need to select the databases from which the analogs will be selected. They should have carcinogenicity data. The simplest way to select all relevant databases is navigate to the endpoint tree and select the cell corresponding to the carcinogenicity. The relevant databases are highlighted in green. To see them at the top of the panel, open Options and then Group by Data for selected endpoint. Select all of the highlighted databases. Now we navigate to the Category Definition section. Select the Cramer Profiler and hit the button By Profiler. A dialog appears showing High Class 3 and the target chemical's summary profiling path. Confirm with OK. The system starts searching for analogs having the same profiling result as the target chemical. The list of analogs is collected. Let's extract the carcinogenicity data. Navigate to the row in the endpoint tree related to the endpoint of investigation. Expand human health hazards and after that carcinogenicity. Open the mouse species and select the row corresponding to summary carcinogenicity. We see the number of chemicals with data points here. There is no data for the target chemical. To fill the data gap of the target chemical, we should go to the next section, Data Gap Filling, and apply Read Across. The dialog shows the metadata information of the data selected for the read across as well as the available scales for carcinogenicity. We do not change anything here and confirm. Some chemicals are excluded because their log cow value cannot be calculated. The initial graph depicts the distribution of the target and analogs into negative, equivocal, and positive carcinogenicity data plotted against lipophilicity parameter, log cow. We should use worst-case scenario approach to make prediction. To adjust the settings, go to Calculation Options, select Data Usage, and after that select Maximal, which implies that each chemical will be represented by its maximal data or its positive value on the graph in case it has both positive and negative data. A helper appears to note that some analogs have different substance type compared to the target. To keep the category consistent, we must eliminate the dissimilar compounds. For this purpose, go to Select Filter Data menu and select Subcategorize. Find and select Substance Type Profiler. The system identifies 7 chemicals which are different to the target, and they are dissociating chemicals. Remove selected chemicals. To refine the category further, we should subcategorize by endpoint-specific profilers associated with carcinogenicity. For this purpose, scroll down to the list of endpoint-specific profiler and select Oncologic Primary Classification. The profiler mimics the Oncologic Expert System for predicting carcinogenicity potential developed by U.S. Environmental Protection Agency. The target chemical is recognized as hydroxyl-type compound. Among the analogs, 66 have some additional chemical classes according to the applied Oncologic Primary Classification Profiler, compared to the target chemical. Let's remove them. All of the analogs in the resulting list belong to the hydrazine chemical class associated with carcinogenicity. However, some of the chemicals have additional structural features compared to the target. To refine the category at this stage, let's use a structure-based profiler such as the organic functionalities. Go to the Empiric section and select the first organic functional groups profiler. There are 4 analogs with different functional groups compared to the target chemical, possessing carboxylic or alcohol fragments. Let's remove them. Now the list of analogs consists of chemicals that are structurally very similar to the target chemical, all of which are positive carcinogens. Let's accept the prediction. After that, we can report the prediction. The first example is done. Now, we are going to learn how to see statistics of the Cramer profiling result for a set of chemicals that are loaded on the data matrix. For this purpose, we use a database from the available in QSAR Toolbox. To do this, we navigate to Input and use the Load Database option. A list summarizing all the Toolbox databases appears. Select the Carcinogenic Potency Database, CPDB, and the substances appear in the data matrix. Let's profile them with the Cramer Profiler. Go to Profiling section, select the Cramer Profiler, and hit the Apply button. In seconds, the profiling result appear in the data matrix. To see the statistics, we need to right-click on the name of the profiler in the endpoint tree and from the menu to select the last option, Profile Statistic. The results appear in tables showing the number of chemicals profiled with a specific Cramer class and profiling path. Click on a row from the table, and the 2D structures are visualized on the right. We can load any of these specific sets in a new document for further analysis by using the option Add in New Document. Congratulations! Now you are familiar with grouping advantages of Cramer toxic hazard classification in QSAR Toolbox. More examples are coming soon. Stay tuned. Contact QSAR Help Desk for technical questions. If your question concerns policy or regulatory acceptance of Toolbox results within EU regulations of ECHA's competence, please refer to the ECHA website directly.